a good idea too. It's a declarative morning. Like, good morning is kind of declarative.
Yeah,
it is a mission statement. What's going on? What is going on, everyone? I hope everyone is having a declarative morning. I know. My name's Robbie. I'm gonna ask some dumb questions up here. I'm gonna be totally honest with all you guys. I'm up here to learn. I did a podcast with Liesel and learned about declarative blockchains and Essential a little while ago. Still very much learning because this is a new concept that I think is new for a lot of people, and it kind of necessitates a paradigm shift in how we think, and then downstream how we interact with blockchains and how we build blockchains. And so if you haven't made that shift yet, it's coming. Just continue to learn. But we're also going to talk about all the things that are part of declarative blockchains and what makes them special, as well as how we're solving for some of the things up here, market making, solving, all things like this. Okay, so why don't we start by a quick introduction, and feel free to get into your project as well and how you're contributing to this space.
Cool. Yeah, I guess I'll start and go down the line. So I'm Cassandra.eth, the middle one here. I'm also Ari in real life. And I work on Arrakis. We are like the decentralized market-making protocol. What we're working to build is basically a liquidity marketplace so that searchers and builders can make credible commitments on locked liquidity from liquidity providers and access this liquidity in nicely constrained ways that's safe for LPs of all types. So we're really excited about it, and it's definitely related. We might not use exactly the terminology of declarative blockchains, but certainly see a lot of similar concepts. So yeah, excited to be here. Thanks.
Yeah, Taker. I go by Xerox Take on Twitter. I'm one of the co-founders of Ayuri, where we facilitate high-frequency trading for searchers, solvers, market makers, trading firms, and whatnot. Pretty much for all of their sort of needs when it comes to essentially very fast trades, essentially. So often, like let's say, of course, if a new recently, of course, shitcoin or altcoin that might have popped up. Very much, of course, that always needs fast execution such that you don't miss out on getting the prices that you need for, of course, blue chips, being able to find the best sort of prices that you can get, especially when you need to be able to hedge out your position in a really nice way. And, of course, for trading firms, very much everything blockchain and very much understanding that sort of account-based sort of model alongside gas and all these different sort of nuances, of course, is very estranged to them. And so we sort of abstract that sort of experience away from them, essentially through the usage of sort of limit order intents alongside sort of how we sort of perform our sort of execution with our protocol. So yeah, excited to be here.
Awesome. My name is Kushi. I lead research at Ethos. We're building a programmable policy layer. Basically what that means is that application developers can create policies that determine how users can interact with their applications. And so policies are a series of constraints, conditional expressions, rules, whatever you want to call it. And we make sure that any wallet addresses or users that are interacting with your protocol adhere to those constraints in a decentralized manner.
Kushi, I think that's a great place to start with declarative principles, because Lisa was just speaking about Pint very briefly, and I think we're going to hear more about it later. But this is, as I understand it, essentially a language to help facilitate these declarative constraints. And so, when you're building policies on Ethos, how are you helping to design these constraints? What are you supplying to your user, right, a developer? How are you helping them build these constraints?
Yeah, that's a really, really good question. I think what we really look at is what users want but can't have, or like it's very difficult for them to achieve right now. One of those things that we've been looking into a lot recently is the idea of creating security parameters. So when you have intent execution or chain abstraction even more broadly, you typically abstract away the actual execution of the transaction. And so users don't know how their transaction is being executed, which is good for user experience and typically like makes their life a lot easier. but it also means that you no longer have control over the actual security parameters around how that transaction is being executed. And so having a general understanding of what are the risks involved with the transaction that's being executed is really important. And so one place that we're really looking into right now is how can we create constraints such that you can build security parameters for users so it doesn't affect their user experience. They don't have to explicitly state exactly what chain they want execution on or what assets they want. But instead, like, how can you just make it so that they can say, I want this to be done secure, or I want this to be done in a compliant manner, or I want this to be done decentralized or through audited protocols. And those are very helpful because users understand those basic concepts, but maybe don't want to make the individual decision on, I want to go into this pool because this protocol has been audited by this auditing company.
Yeah, that makes a lot of sense. At a high level, when we're abstracting chains and we're abstracting accounts, it's like, well, what do we expose to the user? If we have 17 different versions of ETH or USDC, like, we want to aggregate those all into one balance, but ETH on Blast is not ETH on mainnet. And so how much risk do we expose to the end user? Also, just a quick side note, feel free to jump in anytime, as you guys have thoughts. So, and just one more quick other note on Kushi's point here is that, and declarative principles more broadly, a practical example that I think about when I'm thinking in a declarative mindset is I think we've all used Uniswap or some kind of swapping protocol. You see the little minimum received. Well, that is very key to an imperative blockchain. Declarative, that doesn't happen. You can set a constraint. I want to receive exactly this much, and there's no more minimum receive. It's kind of a guessing game. Maybe there's slippage. Maybe you get front run. Maybe you get back run. That is all a feature or bug is up to you, but of imperative blockchains.
Yeah, I mean, I think this is a really interesting a topic. I'm interested in a couple of topics here. Maybe to start with the first one, to respond a bit to what you were saying, I think what I'm noticing, taking a step back, whether you want to call it the rise of intents or the introduction of a declarative-based model or whatever it is that there are these peripheral systems to like core. Like imperative execution layer type protocols, which are starting to complexify and also really tailor themselves specifically to an application. So I think you're noticing in the DEX space, a lot of models, if you squint, you realize they all kind of look the same. In the end, you have some sort of stuff which is not on your like EVM, on the core EVM chain. It's whether they're calling it a coprocessor or a side chain, or there's some way that intents are getting fulfilled and then finally settle on this chain. Like in the DEX space, I've seen almost like 100 next generation DEX models, and they're all somehow like variations on this same theme, whether it's embracing declarativity or intents or something like that. So I wonder if you guys might agree or see it similarly.
Yeah, definitely do agree with, especially if you sort of take it out of the frame of the blockchain, even looking at even the history of programming languages from that of even the 80s, where very much, of course, when some of the first computers were coming up, you had some of these very, very archaic sort of programming languages that essentially had to focus a lot on managing essentially memory and state and storage, essentially that was sort of dedicated towards essentially these specific sort of computer sort of architectures or sort of bits and essentially functionalities that was sort of essentially coupled with the architecture. You soon then afterwards had various different sort of programming languages that came up then soon afterwards came along and abstracted away that sort of architecture, either through, of course, interpretation or essentially through compilation, essentially. By that, essentially abstracting away whether it's a Mac or an Intel computer or whatnot, and then after then, soon enough, pretty much then allows you to be able to essentially run that sort of code your computer program, of course, on any sort of machine that you want, and sort of get the same sort of experience. We're definitely seeing that now as well with a lot of sort of software, sort of even programming languages, sort of a lot of tooling as well, where very much we're seeing it in the infrastructure space as well, where very much a lot of different services, such as that of infrastructure. So, your AWS servers, your GCP servers, like very much, of course, especially when you get to a pretty large, sort of large startup level where, there's 50 servers, and of course, trying to log into every single server individually is insane. And so being able to manage that in a very declarative way just helps a lot in terms of improving that sort of speed, sort of getting you the sort of guarantees that you need. And very much, I definitely do believe that, I definitely do agree that essentially that is the sort of way that we sort of tend towards, that will help a lot with overall just improving the sort of user experience for traders, for people using the blockchain for whatever sort of interests that they may have.
Yeah, it's not just liquidity. And Essential is doing this really generally in terms of state of the chain, which is fundamentally information. And so, it really broadens the landscape for solvers as well, because I think for the most part, solvers are solving intents based on value and token values. But this really opens my mind to like all the other use cases that are possible with solvers and intent-based systems with a declarative type of structure. And so I find that fascinating to think that we might open this design space to an entirely new world that goes beyond just value transfer. Yeah.
I think I hear your point as well. This idea that in general, like in computer science, we sort of work up from really simple primitives and get more and more abstract, and thus you can sort of port that to what's going on in blockchains now in this chain abstraction movement that I think is really bubbling in the as part of the current meta at least. It's similar, like it takes on a similar tone where basically now we're building tooling and infra, which is somehow at a much higher level, where these low-level things like actually running state by calling a transaction on the EVM is going to seem like, is like coding in like machine code directly, and in the future we're going to have this infrastructure, these different kinds of protocols, etc., all these things, but just all building out tooling on a much higher layer, and this is what we're starting to see with everyone focusing and building out protocols and infrastructure for solvers. I also just wanted to very quickly mention maybe. I thought your question around like min amount out as like some interesting thing we could explore in this is pretty cool, because of course, sure, an intent doesn't need to have a min amount out. It could, or a declarative statement could be much more expressive and say, whatever, I want the best price within the next minute. I don't specify any min amount out, but also with
or any latency.
Yeah, sure, but there's also some interesting stuff in trading around like what is really the preference of the trader, because a lot of times, for instance, you could even on an AMM, right? Of course, it's not a great UX, but you can set your min amount out to exactly what you're seeing on the chain right now. It just means you might not actually get a trade through you, and even worse, you might actually revert and pay gas for that revert. However, you do have the ability to express an intent where it basically says, I want the exact price I'm seeing or nothing else. It's just maybe not an amazing UX. Similar things happen, off-chain intents, etc., where yes, you can say I want the very best. Say I want all these things with all these amazing fancy constraints. If they're fancy enough, what happens? You're not going to get executed. And usually, users have a very high like market order type traders. Often people were trying to find ways on chain to express a simple market order. It's just very hard. And so often time preference is the main thing. They're not that worried about price. Maybe this is too much of a niche subject just about trading stuff, but I don't know. I think it's interesting.
Yeah, no, I think you make a really good point, especially picking up that sort of what you mentioned, of course, when it comes to chain abstraction, that, some of the sort of questions, of course, that we're seeing, and that sort of question, of course, that sort of narrative and whatnot is the fact that there's always people that want that very, very specific, let's say, sort of need of, let's say, just transacting on one specific chain, or requiring one specific token because of the fact that it might unlock another sort of functionality, or it's a certain perhaps they associate it themselves with a certain risk involved and whatnot. And I definitely think that sort of bring it back to this sort of having these sort of declarative languages, it helps a lot to be able to also always have this sort of space and the freedom as well to sort of get into the sort of nitty-gritty sort of low-level sort of constraints, where essentially you're able to pick apart essentially like some of these specific wants that people may need. I think that when it comes to like the sort of like, let's say, as we sort of start essentially building some of these different sort of declarative languages, it helps a lot in order to know that essentially that with these sort of languages are there in order to help a lot with essentially essentially standardizing some of the expressivity, but not at all like essentially holding back the sort of freedom that people want to express themselves, and making sure that essentially they're not allowed. Of course making sure that they're able to whatever essentially the sort of intent or whatever sort of thing that they require can always be done essentially. That sort of backwards compatibility in a sense of being able to do anything that they want without being held back.
Yeah, I think it's actually a very, very difficult balancing act, because you want to have this incredible expressivity on your network, on your chain, on your language, but then you also want to make it so that users aren't overwhelmed, so that they can express intents that are actually executable, and that gets really tough. And I think what's interesting is a lot of intent-based systems today, the way they're used is for like a simple cross-chain swap, right? Or trading, in which case speed is really important, or maybe price, but even then it's usually like speed within some kind of price range. And so I think when we actually see how constraints can be used to their maximum ability, it's not going to be in the trading front as much. It's going to be in more basic strategies. So if I want to just deposit some asset into a high yield vault, but I don't want to look at the hundreds of different like options that I have, then I'm just going to say, give me a yield within this range with these simple constraints, right? Like maybe I just want a protocol that's audited and has never been hacked, and that's like the safest I can assume. And then I want a 5 to 6% yield. And hopefully that's possible, but even if it's not, maybe you can bring it down a bit. But I think it's like figuring out that perfect balance between how much expressivity can you give to the user such that they're not burdened by transactions reverting over and over again. But I do think constraints are not going to be used very much in trading. I think it's going to be on a lot of those simpler strategies.
I think that's really interesting, and I agree that, basically all these different solutions at this potentially declarative layer or higher layer in the stack, depending on how you want to see it, I think where they're going to end up competing is on, this interface. So, okay, in theory, it sounds beautiful. We can make any kind of expressive constraint system, but which ones will actually exist, and which interfaces will sort of serve the needs of users in a way that's palatable to them, but also gives them great expressivity, also gives them the ability to not lose some of the like low level, to be able to say low level things, because sometimes when you abstract everything away and you say, oh, in our system you just always say, make me the only type of intent you can express is take my money and make me the most money. Well, maybe I want to do something a little more. I want to say, well, if something happens on the Ethereum state like this, please revert. And I actually want the ability to do that. So all of these complex choices that you'll make about what interfaces you want to actually expose to the user, and then also how to make that into some palatable actual user experience. I think these are the edges that all these different solutions are really playing on, more than maybe, I think sometimes people get really caught up on like the theoretical part, and I think theoretically things are converging, looking pretty the same. Actually what we need is people trying out these different things, seeing what intents users can actually express and get executed and so forth.
Yeah, I tend to agree with you guys. I mean, we're talking about what constraints we put on the constraints that we're flowing through the system. So I tend to agree. I think maybe 90 to 95% are going to look like the same type of transactions or intents that we're flowing through the system, and there's just going to be little tiny tweaks like what price range, what time frame, what applications, audited or not, that I am choosing to interact with. And Kushi brought up the cross-chain case, which I find fascinating. I was at Everclear, the clearing day yesterday, Raise your hand if you were at the clearing day. Come on, no one. It was just me.
All right,
All
there
right, I
was
see
one,
one hand. All right.
in the bag.
Well, they basically said declarative without really saying it. They said that, you know, you as a solver are able to choose, hey, I want to rebalance my liquidity on only ZK Sync and Arbitrum, for example, or only audited protocols. And so by setting those constraints, the solvers are then going to rebalance liquidity across those chains and get solved on those chains, specifically only those chains. And so that in essence is a declarative principle in which they're designing it. And so, you know, I think this declarative nature of things, the mind virus has already started to infect people. They're just not saying the word declarative. And so I think part of this is going to be to start to recognize these declarative principles that are inherent in some of these systems, even if people aren't saying the word declarative just yet. And so when you're thinking through this, I'm curious if you've seen declarative programming and declarative principles in some existing protocols or applications. You know, Essential obviously pushing this and just coming out and saying it. But I'm curious, have you seen declarative programming in other crypto Web3 decentralized spaces? If so, could you just kind of provide some examples so that we don't get caught up in the theory and we have something to point to in practice?
Yeah, for me, I feel like it's like this is partially, I mean, it's not theory, but it's like we love to noodle on vocabulary a lot, right, in this space, which is totally fine. I think it's even important. It can be necessary because each way that we do it clarifies the way that you're looking through that problem. But I see these, like this whole chain abstraction, the frontier research people and the cake framework, to me seems like very similarly, oh, hello, might not be using the language of declarative blockchains, but is, I think, dealing, for me, in a really similar space. What I was saying before is that in the end, we can talk all day about the different ways, and that by using the vocabulary that they use, they frame the problem maybe in a slightly different way. But at the end of the day, you squint, all these things look pretty similar, and what I'm most interested in is who's going to expose interesting interfaces to real users that actually gives them real utility for what they want to do with some application. And the vocabulary that you use might help you cut the right path for your project to find the right fit there. But yeah, in the end, it's like I want to see tangible things, and what we see tangibly today, in my opinion, is, you know, simple initial stuff, things like cow swap. You know, the intents actually being used and fulfilled. I think this is already moving in moves in that direction, and you could plausibly call it like declarative programming, the way they make their solutions or something. Not sure, but yeah.
Yeah, I think one of the sort of this might sound a bit pretty, of course, strange or whatnot, but I definitely think that's very much one case of course, the sort of declarative nature. Perhaps a very, very sort of constrained or very, very primitive is actually that of these sort of strategy votes that you sort of see on-chain in DeFi, where very much they sort of fit this sort of, they allow you to be able to access a certain type of, let's say, exposure or set up a certain sort of position for you. Of course, in the case of, let's say, a yearn vote, it's, as Kushi was alluding to, that very much it's a case in which it's able to help you aggregate between these various different bits of yield. Of course, we've seen in cases such as that of FINA as well, where it's, of course, they offer, essentially give you this sort of exposure, essentially, to this sort of funding rate arbitrage that essentially they're performing. But of course, when you sort of look behind the hood, that sometimes it's the case in which it's not exactly as, let's say, incredibly neutral as you would have hoped. Of course, in the Athena case, it's a bit more easy to point out, where essentially they're very much how, of course, they purchase, of course, spot on chain, but very much when it comes to the sort of perp side of things, that they very much offload it to these essentially off-chain market makers, essentially behind the scenes. And now with that, essentially, of course, not a lot of people are drawing attention to it just yet. But that essentially, this sort of schematic, of course, is very, very, of course, very, very centralized. and that almost like as Lizelle puts it, essentially that these sort of solvers sometimes have, or solvers or market makers have a bit too much control, essentially, even though it's a case in which they're offering something that is able to be, that is sort of declarative in nature, but very much it's a case in which essentially it's still very centralized in a sense. I think once we sort of find ways in order to essentially either essentially hold these sort of different counterparties to account, whether that be essentially through essentially tokenize the creation of these sort of DeFi primitives that are able to sort of emulate these sort of payoffs that are required, such that we don't need to go to these off-chain actors all the time. That very much then we're able to really, really embrace a sort of decentralized, declarative nature where where the sort of where you have complete freedom essentially to your sort of the sort of wants of, let's say, being able to aggregate and rebalance between different chains, as Ari said, as well as also be able to, let's say, be able to manage your positions on chain completely, to that of being able to get whatever sort of, let's say, of course, payoff structure or for whatnot for your trading strategy.
Yeah, I mean, I think both of you guys completely hit the nail on the head in the sense that offloading is what I see as like just a key indicator that something is declarative, right? Like whether it's chain abstraction, intent execution, or even just like a yield strategy, it's all just having some other entity do the actual execution for you, do the strategy for you. But I think that concept of off-chain entities versus on-chain entities doing that for you is very interesting. And I wonder what you see as the key unlocks for moving that off-chain offloading to on-chain strategies.
So I definitely would say that I think that there's one part to it where very much we're still at a stage that essentially some of these DeFi primitives are very, very hard to access. They're not exactly composable. It's very much a case in which it's actually a bit difficult, actually, if you were to have a solver come in and try to offer you that a sort of on-chain position like that of, let's say, Hyperliquid, of course, where it's on a separate app chain, or it sets up a GMX position for you. Of course, trying to essentially chain abstract that, unfortunately, right now is very, very infeasible. Very much there are sort of ways that we at Iori are sort of looking at it, where if we're able to essentially let's say, potentially even tokenize these positions, or either emulate these positions as tokens, that very much then they sort of fit naturally in that sort of model of essentially chain abstraction, where very much now and then much more composable, they're easier to move around with, they're decentralized, it's on-chain, you can track the balances and whatnot, and that very much is the case in which you're able to move them around, and now they sort of fit into that model, where essentially now, pretty much, once a, let's say, bridge or, of course, a chain abstraction solution is available for ERC20s, they can be widely accessed.
Yeah, for me, really interesting question. I like to think of it less about on-chain versus off-chain, more about what kind of decentralization and what sort of trust assumptions do you want. And the reason is because a lot of things are sort of mixing and matching. Some parts of critical state need to be run and enforced on-chain on like Ethereum L1. Other parts are on these side chains or on a TE, people using things with TEEs, people using roll-ups versus chains that don't actually post data availability to the L1. So many different things which are these on-chain, are they off-chain? What's important to me is what is the set of trust assumptions you want to make, and how much are you offloading to a central party, and where is that good, right? In Athena's case, they do offload to a certain extent to some custodians. That's because they're giving this unlock for these on-chain participants to actually the only way to capture this basis trade is to have this part on a SEX, which is not observable to the chain. And so they seem to, I don't know much about Athena to be honest, but they seem to split it over a couple custodians or something, try to create a trust assumption that they think is palatable and useful. I think more decentralized solutions will be more exciting, and you can do more because, of course, it's very easy to be declarative. You go completely decentralized again. You can give your money to a money manager and say, please make me money, right? This is a very declarative style statement, but it's also extremely centralized and, you know, not really any new innovation in financial technology, as opposed to some of the things that are, you know, try to create a much more innovative or much more contemporary trust model with all these new systems available to us.
Yeah. Switching gears a little bit, but just zooming out in terms of this chain abstraction thing that we've been alluding to and everyone's kind of heard about. I'm curious, when you guys approach chain abstraction and you see the way that we're organizing the different sets that are playing a role in this declarative architecture, you know, what's good about it? What's bad about it? Like, if you were to look at it, you know, I think it's it's a very relevant piece of research in trying to consolidate these teams and these thoughts so that we're not all just repeating and building the same thing. But I see it as a starting point that we can build from. And so if we were to, you know, maybe it would be helpful if you each kind of describe where your project fits in the cake framework or in chain abstraction more broadly, but then also like how you see some of these different layers working with one another.
Cool.
Like.
Yeah. Sure. I'll jump in. Why not? Yeah. I feel like our goal, right? We want to be this liquidity marketplace that allows the possibility, you know, try to make it possible to retain this vision where passive asset providers can still participate in some form factor in market making. And we see that like what we want to do is have this marketplace where their liquidity is locked behind some door where builders, searchers, generally market makers and sophisticated market making participants can make these credible commitments on like in order for them to be credible, this means on some sort of decentralized system with something at stake, maybe parallel to the important execution environment, think the Ethereum L1 or maybe some L2. And so these market makers make these credible commitments, and then this allows them, like just in time, to actually access the liquidity based on the, you know, what they committed to about how they are going to use that liquidity in this block. And so, yeah, I would say we're pretty low down in the stack, right? Liquidity is down on like the lowest layer of the cake, almost at this kind of sequencing lowest layer, but it's about taking liquidity and creating the right interfaces for that, these solver type participants, that solver layer, specifically the ones who are interested in making markets and giving them the right interfaces to do that on liquidity. That's what we're looking to do.
Yeah, I think a sort of general theme that I think pretty much all three of us would be like sort of mentioning is the fact that, you know, we're sort of very much driven by the North Star of users and focusing on a specific segment that essentially we want to achieve essentially a really, really essentially well-defined experience essentially for them. You know, in our case, very much it's a case in which, of course, as I mentioned, that, you know, we focus a lot on essentially these different trading firms that want to be able to execute very quickly, such that they can understand their risks and be able to essentially minimize that as much as possible, as cheaply as possible, and be able to execute these sort of trades such that they're able to do whatever sort of, provide whatever sort of services when it comes to market making or essentially trading to help with, let's say, token listings and making sure that essentially there's liquidity there from even decentralized exchange venues in order to backstop the centralized exchange liquidity to, of course, you know, finding these different arbitrages and synchronizing these different markets and whatnot. And that ultimately, you know, we want to make sure that that experience is really, really clean for them. I think where essentially a chain abstraction, as well as a lot of these sort of chain abstraction, declaratives like sort of blockchains and all sorts of these different sort of technologies that we're seeing right now are very much helping, even though they might not explicitly say it. Of course, I can understand, you know, the fact that, you know, they've sort of defined this meme really, really well for users, is that actually for a lot of different trading firms, that it helps them quite a lot in reducing risk, ultimately, that, you know, pretty much these sort of different bits and bobs, these different sort of things that are being looked at, especially when it comes to, let's say, cross-chain, omni-chain execution environments, where, of course, there's a lot of risks involved, that being of like finality to, of course, you know, state drift, that very much a lot of these sort of things, like, you know, some of the stuff that, of course, some of the stuff that the Frontier research guys are looking at with resource locks, to essentially, of course, trying to find ways in order to essentially provide upfront or essentially clear out settlement such as that of Everclear, where essentially that sort of liquidity is backstopped in a sense. That very much it all really helps our users and whatnot, very much with essentially reducing that sort of risk and being able to provide that sort of availability as close to 100% as much as possible. So we definitely do find that, very much a lot of these sort of protocols, even though, of course, they mean narrative quite a lot, that they're very helpful in terms of like overall this, and whether they might not realize it, helping us a lot in terms of essentially helping ultimately some of our users essentially reduce the risks when it comes to trading on chain.
Yeah, I think for us, it's like there's two parts of the chain abstraction framework that we typically fit into. One is the very clear low-hanging fruit of policies, right? Like policies are up near the user. Users have policies on how they can control like their strategies, their intents, whatever they're expressing to be executed. And so we do a lot on the constraint side. We do a lot for increasing user expressivity while also making it as simple as possible. But the other side of it is also on the liquidity layer. So it's like one thing about like a lot of these execution systems is the liquidity can flow from place to place, and it's very hard to track where that liquidity is going, where it's coming from. Users bring in assets, those go into solvers, different assets go out. So there's a lot of liquidity tracking that happens there. And policies are really vital there as well in terms of maintaining like risk-free liquidity. So a lot of market makers want to ensure that their liquidity stays clean, stays safe, and so risk management is very important there as well. So policies actually fit in on two sides of the stack. One is very close to the user so that users can express their policies on where they want their assets to go, but also on the side of the liquidity providers so that they can control where their assets are being deployed, what they're being used to solve, so that their assets remain within their risk framework as well.
Awesome. As we come up on time here, I'm reminded of the FAT protocol thesis, FAT application thesis, and this general idea of value accrual. And so, we can kind of frame this in a few different ways, but one of which would be the chain abstraction cake framework, as far as whether or not this the value is flowing down the stack or up the stack, And in this world of microservices that is getting increasingly modular as we unbundle and specialize, I'm curious, where is the value, where is the usefulness accruing? Like in your perspective, who is providing the most functionality and ought to accrue the most value for providing that functionality? Is it the top of the stack closest to users or trading firms, or is it further down closer to settlement or liquidity? Yeah, any perspective on? Again, we can go out of order if you guys like, but
Please.
you've been jumping in.
Yeah, I can go ahead. I think one of the interesting sort of parts to this is very much trying to frame it in a way where essentially whoever essentially provides the order flow, whoever processes the order flow. Whoever processes the order flow, whoever essentially settles the order flow, does whatever with it, essentially, isn't being overpaid. Very much, of course, we're seeing, especially like in, let's say, in specific certain segments of the market, such as that of ZK proving, that of course there's all sorts of different sort of auction marketplace mechanisms and whatnot that are there in order to pit these different sort of ZK provers together and be able to essentially compete on price, such that ultimately it provides much more better guarantees, much more cheaper essentially proving times, much more cheaper proving costs essentially ultimately to these different, let's say, ZK rollups or ZK applications essentially, and ultimately of course then that leads to different costs. Very much also seeing, of course, the same as well, being that happening as well in DA, and very much, of course, people understanding that very much, of course, paying for Ethereum DA is often quite a lot, and that very much, you as an application or you as an application overpaying for DA, or your users overpaying for DA, of course, is like a worse thing that sort of comes off as that essentially offering a worse experience to them. So very much we're seeing that a lot of like things transition towards essentially applications and these different protocols, these different applications, essentially of course building a layer 2s or essentially becoming their own sort of app chains or even apps that are much more self-aware and essentially knowing to essentially look at ways to essentially see how they can capture value and reduce costs such that ultimately they give more back to the users. I definitely think that that has helped a lot in terms of pushing it towards essentially pushing the narratives more towards essentially the fat app thesis, where we're seeing that apps are there in order to provide they're the first touch point that a lot of end users sort of interact with, and that very much they're there in order to help provide much of the service as there as possible without you having to jump between all sorts of different like sort of doors and whatnot in order to get the experience that you should have been expected.
Yeah, I think I have a similar take. My main idea is that everything stuck in the middle, if it's properly decentralized, ends up being erased to zero, because decentralized networks typically promote competition, and so all of the players in that ecosystem may get some reward out of it, but ultimately you're like competing over getting the fastest proving time or the lowest proving cost or something like that. So you're always racing down to zero. And so a lot of the value capture happens at either side, either closer to the user or closer to the liquidity. Everything in the middle essentially just keeps racing to improve user experience or improve execution for the user. So I think it's like front ends at the end of the day get to control users, get to try to get the most users in. They accrue a lot of value, hence why Uniswap has a fee for their front end. Like front ends accrue tons of value because they get to control the user. But on the other side, where the liquidity is, that's also what powers markets, right? And so liquidity actually has a lot of value accrual as well. It is literally where all of the value lies. But I think that's often overlooked because owning the user is very important. But we don't have a lot of users. And so I think looking at both sides is very important, where liquidity is a pretty great place for value accrual in addition to front ends.
One great thing about not going first is that then I can just say, yeah, I totally agree with that. That's what I would have said. I really, really echo what I just heard, which is that, at Arrakis, we're thinking a lot about liquidity providers, and I do see liquidity as, hopefully it might even change, but today it's one of the scarcest resources in blockchain. It's where a lot of value still sits, and you see this in the way that the different blockchains are, you can have all these amazing models or whatever, but then they still have to compete super fiercely for this liquidity. And if you get liquidity network effects, no matter what your model or your idea or your branding is, things start rolling a lot more or a lot better. So I see a ton of value on the liquidity layer, and then as well, yeah, of course, owning the user and like basically apps being able to deliver real real experiences to real users. There's like tangible, very scarce, important value there that just never goes away, right?
In hindsight, it seems so obvious. It's both the fat applications and the fat protocols, and then but it's something that I hadn't quite thought about. That everything in the middle is what gets commoditized. I'm gonna keep thinking about that. Thank you. Thanks to our panelists. Give it up for our panelists. And thanks everybody for listening. Thanks, Grant. We got time for questions or no? Keep it rolling?
Unfortunately, no.
All right, we keep it rolling.
Sorry.
Thanks everybody.